Assalamualaikum. Okay guys, let's discuss one example. How do we calculate the equivalent capacitance and how do we calculate the total charge stored by each capacitors which is arranged in series and parallel. Okay, so this is the example. Okay, example 2, find the total potential difference across the capacitors X, Y, and Z and find the charges reside on the capacitors X, Y, and Z. Okay, so normally to answer this question, we need to know how to calculate the total or equivalent capacitance. Based on that, we may calculate everything needed here, which is the potential difference across each capacitors now, which is X, Y, and Z. Also, the charge stored by each capacitors here, which is X, Y, and Z. All right, which is arranged in parallel, also in series. Okay, let's start. Okay, to calculate the equivalent capacitance. Okay, now there are three capacitors, which is X, Y, and Z. Y and Z just arranged in parallel, while Y and Z just arranged in series with X. So now how to calculate the equivalent capacitance or total capacitance? First, okay, we just combine Y and Z to be one, to be like this. Okay, all right, so Y and Z are arranged in parallel. So for any parallel arrangement, okay, we just total up the values directly, which is CYZ equals to CY plus CZ, okay, to be like this, become 1 already. Okay, so the values given is 1 micro and 2 micro, and then you will get 3 micro. That one is capacitance of YZ, all right, and then CYZ and CX, they are arranged in series. For any series arrangement, remember we need to calculate the equivalent capacitance using 1 over C, isn't it? So 1 over Cx plus 1 over Cyz, okay, equals to C total here lah, which is Cxyz. All right, so 1 over 6, okay, this one 6, and the total values here before is 3, so 1 over 3 micro, okay, and then you will get 2 microfarad. So this is C total or C equivalent. Okay, other information should known by students is about the potential. What happened to the potential of Y, Z, also X? Okay, so remember, for any parallel arrangement, the potential should be the same or equal to each other. So CY and CX just arranged in parallel, so that V across CY equals to V across CZ. Okay, so they are equal in potential. All right, and then as we know, CYZ combined already to be 1. Okay, they just arrange in series with X, isn't it? So in series arrangement, remember V total equals to VCX plus VCYZ. Okay, V total equal to VCX plus VYZ, where V for CY and CZ is still the same. That's why we have 3 different equations, but still the same actually. Okay, where VCYZ equal to VZ or VY. See, they are equal because they are arranged in parallel. All right, so this is potential. Okay, what happened to Q? Okay, this is the situation now. Okay, so for Q, all right, so remember by calculating C total, okay, you will get C total and V total given already. So we may calculate Q total, where Q total equals to Q total here, which is Q of X, Y, Z. All right, and then CX and CYZ, they are arranged in series, so their Q should be the same. So Q stored by X equals to Q stored by YZ, which is equals to QXYZ. Okay, so that is the keyword here. For any series arrangement, Q total equals to QX equals to QYZ, which is equals to here. All right. Okay, and then for CY and CZ, they are arranged in parallel. So in parallel, Q total before here, which is QYZ, equals to QY plus QZ here. All right, so total up this 2Q, and then you will get Q total here, which is equals to QX equals to Q total. Okay, so that one for any parallel arrangement. Okay, now how to answer the question? They ask you to find the potential across each capacitor, which is X, Y, and Z. Also the charge stored by each capacitors here. All right, so we just start by using this diagram. V total given already, which is 12 volt, and then C total calculated just now before, and then by using Q total equal to C total V total, you will get you will get Q total, okay, where Q total now equals to 24 microcoulomb. And remember, Q total here equals to Qx also equals to Qyz. See, so we have answered Qx. Okay, all right. And for how to find V, okay, by knowing Qx, by knowing Cx is 6 microfarad, Qx equals to 24 microcoulomb because they are arranged in series, isn't it? So Q still the same. So using Q and Cx, then we may calculate V across Cx, which is 4 volts. Okay, all right. And then according to the series arrangement before, Vx plus Vyz equals to V total. Okay, V total given already, which is 12 volt. V across Cx calculated just now, which is 4 volt. Then we may calculate V across Yz here. Okay, so that you will get V across Cyz is 8 volt, which is equals to V across Y, also V across Z here, because they are arranged in parallel, isn't it? So here is 8, here also 8 volt. Okay, so by getting V across Y also Z, and then by using this equation, okay, Qy equal to Cy V Cy here, and then Cy given already, which is 1 microfarad, V Cy calculated just now, which is 8, and then you will get Q stored by Y. Okay, and then you just do the same thing in calculating Q across Z here. So Qz equal to Cz V Cz. Okay, C of Z is 2 microfarad, and V across it is 8 volt before, and then you will get this. Or remember, Q plus Q equals to Q total here, which is equals to Qx, isn't it? We may use this equation too, which is Qyz equals to Qy plus Qz, where Qyz equals to Qx, which is 24 before. Alright, so Qx also 24 equals to Q total. They are arranged in series before. And then Qy calculated before is 8 microcoulomb, so that you will get Qz. See, it's quite easy. So normally to calculate everything needed here, we need to reverse back. First, we just simplify all the figures now, or the diagram, in calculating C total. And then to calculate everything, we just reverse back. We just move backwards here. Okay, and then you may answer all the question. Okay, that's all. Bye. Thank you.